Okay, so we'll talk about a little bit about the fundamental counting principle here. So the fundamental counting principle, I usually abbreviate it as FCP. All it really says is if you have one thing that can be arranged A ways, and then another thing that can be arranged B ways, then you can arrange them together with each other A times B ways. So as a really quick example, if I have 2 shirts and 3 pairs of pants, then I would have 2 times 3 outfits. Okay? So that's all the fundamental counting principle really is. So let's look at a couple examples here. So let's say you need to make a 4-digit PIN number. So these spaces here represent my 4 digits. So for my 4 digits, I could have anything from 0 to 9. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Or 9, I should say. So for the first digit here, I could have either one of these possibilities, and there are 10 of them listed. So 10 possibilities. Okay? Now, typically when it comes to a PIN number, you could reuse a digit. So for the second digit here, I could have either one of these digits again. So 10 more possibilities. For my third digit, of course, I could have 10 more possibilities. And for my fourth digit, 10 more possibilities. So if I've got 10 ways to arrange this digit, and 10 ways to arrange this digit, and 10 ways to arrange that digit, and 10 ways to arrange that digit, then I could multiply these together to find the number of ways to arrange the 4 of them together. So 10 times 10 times 10 times 10 is 10,000. So that tells me that I've got 10,000 possibilities here. So that's with repetition allowed. So you could use a digit more than once. So I could have a valid PIN would be, say, 1136. Okay, I could repeat the 1. I don't have to, so I could go, say, 3147. That would also be a perfectly valid PIN. So I can repeat, but I don't have to, and that would give you 10,000 possibilities. But how about if you were limited to not being able to use repetition? Now this typically isn't practical, but just for example's sake, my first digit would still be able to be either one of these digits. So it would be 10 possibilities for the first digit. Okay? Now the second digit though, I'm not going to be able to use whatever digit was used here. So let's just imagine for a second that I used a 7 in this place right here, the number 7. Well, that means for the second digit I could have any of 0, 1, 2, 3, 4, 5, 6, 8, 9. So instead of having 10 possibilities, I've actually now got 9 possibilities because I used the 7 right here, but I can't use it again. So that gives me one fewer choice here, one less choice. Now, the next digit, the third one, well, I've got 2 digits chosen now, say like a 7 and a 4. I can't use either one of those here. So I can't use the 7 and I can't use the 4. Well, that would leave me with 8 possibilities. Okay? And now, with the last digit, I can't use either digit that was used previously. So instead of having the 10 possibilities here, I would only be able to use 7 of them. So you see that my number of possibilities decreases now. So it becomes 10 times 9 times 8 times 7. Of course, I didn't multiply those together before starting this. So that's 90 times 56, which is 5040. Okay? Another kind of example. Let's say you're looking at a Newfoundland license plate, or Newfoundland postal code, we'll say. So a typical postal code would be, say, like A2H4N2 or something, right? Or some kind of number like that. So in Newfoundland, the A2H is actually, well, in Corner Brook. Is it in Newfoundland? Yeah, it's in Newfoundland. The A2H is standard, right? It's these guys that can change. So how many possibilities do we have with just these guys changing? Well, really, these three are staying the same. It's only these three that I have to worry about. So I've got three things here. Alright? The first one here is going to be a digit. So it could be anything from 0 to 9. 10 possibilities, right? Okay. The next one here is going to be a number, or sorry, a letter. So it could be anything from A to Z, right? So I would have 26 possibilities right there. And the last one again is a number. So sometimes you can have repetition. So we'll say that you can in this case. So that will give me 10. So the number of possibilities here would be 10 times 26 times 10. So that's just 26 times 100, which is 2600. Okay? And that covers a couple examples using the fundamental counting principle.